Today we're going to review adding and subtracting fractions with unlike denominators. Please make sure you have your graphic organizer ready to go to help take notes. Well, I learned the hard way that I can only upload videos that are 15 minutes long, so we're going to go through this pretty quick. Please feel free to stop, rewind, ask questions when you see me, take notes of questions, and we'll hopefully get this covered. When you add fractions, it's much easier when they have the same denominator. To add fractions, they must have the same denominator so that you realize if you're adding the same size of pieces together. If they have different denominators, then you can't compare the two different size pieces. When the fractions do have the same denominator, then you 1, 2, 3. Number 1, add the numerators together. 2, leave the denominator the same, and then 3, reduce. Subtracting fractions is the same. You must have the same denominator once again so that you have the same size pieces. Again, it's simple as steps 1, 2, 3. You subtract the numerator only. Step 2, leave the denominator the same, and then 3, reduce. As you notice in the other two slides that we keep talking about the denominator. The denominator is very important when adding and subtracting fractions. When the denominators are the same, then you're working with pieces that are the same size. For example, if you look at this first circle, it's divided into halves. The second circle is divided into thirds, and the third is divided into fourths. These pieces right here, this 1/2 is completely different size than this 1/3, which is completely different than this 1/4. You can't add those pieces together when they're not the same size, you can't have a good comparison between them. So the denominator must be the same so that you realize that you are adding or subtracting the same size pieces. Now, life would be wonderful if the denominators were always the same, but unfortunately they're not. So if you do have to add or subtract fractions that have this different denominators, you need to find the least common multiple, or the LCM, of the two denominators, and then you can change that into the common denominator. To find the least common denominator, I know we learned this last year, but here's a quick review. You take the two denominators, in this case 9 and 6, and you're going to do the prime factorization of them. Prime numbers, please remember, are numbers that only have two factors, one in themselves. Composite numbers have more than two factors. Now 9 is composite because it not only has 1 times 9, but you can also take 3 times 3. So we're going to take the 3 times 3 and we're going to branch off of the 9. Then we're going to look at each 3. Now 3 is prime because you can only multiply 1 times 3 to get 3. So when you have branches and that they end with the prime numbers, then you are complete, and the prime factorization of 9 is 3 times 3. Prime factorization of 6, we need to find two numbers that will multiply and give you 6. 3 times 2. If you look at 3, you ask yourself, is 3 prime or composite? In this case, 3 is prime and 2 is prime. When you end all the branches with prime numbers, you just write those down. In this case, it would be 2 times 3, and that's the prime factorization of 6. Now, to use this to find the least common multiple, the first thing you look for in the prime factorization, which is this equation and this equation, first thing you look for are matches. Now, if you see a 3 here and you see a 3 here, we have a match. You write that one time. There are no other matches, so now we're just going to go back and we're going to grab all the leftovers. So we're going to grab that other 3, and we're going to grab this other 2. Now they've all been chosen, and then we multiply 3 times 3 is 9, 9 times 2 is 18. 18 is our least common multiple. Please stop the video at this point to give you a chance to write all these notes down before you go on to the next slide. Now once you find the least common multiple, you're going to need to write out equivalent fractions with our new denominators. 1/9 plus 1/6. We know that 18 was the least common multiple, so we're going to have to make that our new denominator. To do that, we have to look at how we got from 9 to 18. What we did is we took 9 times 2 and that got us 18. Whatever you do to the bottom, you have to do to the top to make it fair and equivalent. 1 times 2 is 2. Now what we just did is we took our original fraction 1/9 and we wrote an equivalent or equal fraction to it with the denominator of 18. Anytime you take the numerator and the denominator times the same number, in this case 2, you'll get an equivalent fraction. What that means is that 2/18 takes up just as much space as 1/9. They're equal. If you look at 1/6, we took 6 times 3 to get us the 18. Well, to be fair, whatever you do to the bottom, you have to do to the top, so we're going to take our numerator times 3, and 1 times 3 is 3. Now, if you notice, we now have an addition problem where they have the same denominator of 18. So now we're back in business. We just simply need to add the numerators 2 and 3, and then we keep the denominator the same. And in this case, we cannot reduce. There's not a number we can divide out. And so 5/18 is our final answer. Please stop the video here so that you can make sure you take all of these notes, write down any questions you have. On the next slide, we'll practice doing this again. Now we're going to run through some of these problems together. 5/12 plus 3/4. Now the first thing you're hopefully going to notice is that you have different denominators. So we're going to have to find a common denominator, or the least common multiple. Now in this box over here is the place where we can do our prime factorization trees. So we're going to come over here and we have 12 and 4. You can write out 2 factors of 12. 6 times 2 would work. 3 times 4 will work, and it really doesn't matter which one you go with because in the end you'll get the same answer. So let's go with 6 times 2. Now 6, if you ask yourself, is it prime or composite? 6 is composite because we have more than 2 factors. We have more than just 1 times 6. To get 6, we can also take 3 times 2. Now we're down to this branch of the 3. Well, we learned earlier that 3 was prime, so we're going to circle that because that part of the branch is done. 2 is prime, so we're going to circle that, and 2 is prime here. Once you have prime numbers at the end of every branch, you can write out the prime factorization. For 12, it would be 2 times 2 times 3. Now for 4, we're kind of limited. The only 2 factors that will go into it are 2 and 2, and both of those are prime. So we have 2 times 2. Now the least common multiple, we would look for matches. Here's a 2, here's a 2, so we write it 1 time. Here's a match of 2 and 2, so we're going to write it 1 time. And then we go back and we grab whatever's left over, in this case 3. 2 times 2 is 4, 4 times 3 is 12. So now I'm going to come back over here to our original problem, and we're going to find some equivalent fractions that have denominators of 12. Now, if the denominator stays the same, in this case 12 stayed 12, then the numerator stays the same. So 5/12 is equal to 5/12. At the bottom, we took 4 times 3 to get 12, so we need to do it to the top as well. 3 times 3 is 9. Now where we have the same denominator, we can just add our numerators, 5 and 9. 5 plus 9 is 14, and the denominator stays the same. Now in this case we can reduce by 2. That's going to give us 7/6, and 7/6 is improper. The numerator is bigger than the denominator. So what we need to do is, I'm going to work up here at the top where I have a little bit more room. We're going to take 7 divided by 6, or the numerator, divided by the denominator. 6 goes into 7 one time, and we are left with a remainder of 1/6. So 7/6 is equal to 1 and 1/6. So this is our final answer. Please stop the video so you can make sure that you get this all written down on your notes before you go on to the next slide. Okay, let's do another one together. This time we're going to take 2/7 minus 5 21st. First thing you notice is, of course, the denominators are different, which means we're going to come over here to our workbox, and we're going to find the prime factorization of 7 and 21. Now, 7 Do you know of any factors that will multiply and give you 7 other than 1 times 7? No? Well, that means that 7 is prime. So we're just going to bring it right down, and the prime factorization of 7 is simply 7. 21, we can take 3 times 7. 3 is prime, and 7 is prime. So the prime factorization is 3 times 7. Now the least common multiple, the first thing we're going to look for is matches. We have a 7 in both equations, so we have 7. And we go back and grab the 3. 7 times 3 is 21. So 21 is going to be our least common multiple in our new denominator. So we go back to our problem and we turn the denominators into 21, and we're going to find equivalent fractions. To get 7 into 21, we took it times 3, which means we need to take the numerator times 3, which is 6. If the denominator stays the same, the numerator stays the same. And now we're ready to get to work. But I hope you also noticed we're not adding this time. We're subtracting. Subtract numerator minus numerator and keep the denominator the same and reduce. In this case, we can't reduce. So 1 over 21 is our final answer. Please stop the video here so that you have time to write down and take some notes. Now it's your turn. I want you to work out 3/8 minus 3/16. Use the workbox to do your prime factorization. I want you to stop the video now so that it gives you time to work. Here's another opportunity. This is your turn. I want you to take 3 over 36 plus 3 over 9. Work out your answers and have it ready to go. This concludes our video today. Please make sure you bring your graphic organizer to class tomorrow. The magic word that I would like for you to write at the top right-hand corner of your paper is happy. I want you to write the word happy at the top right-hand corner of your notes, and that's the magic word for this video. Have a great day, and we'll see you tomorrow.